So let's think about the two common problems. One is a problem where there is a motor neuron disease. And one example, so if this is broken, what happens? Well, polio is an example of this, and a variety of neuromuscular junction problems such as myasthenia gravis, as well as a peripheral neuropathy, which is called Guillain-Barré, and that affects, so polio affects the motor neurons, Guillain-Barré affects the nerves, and the neuromuscular junction affects this connection. Wherever in the connection between motor neuron and skeletal muscle is affected, what types of movement are gone? Well, reflexes can't happen. Stereotypical movements can't happen. And actions can't happen. So if the motor neuron is gone, there is a complete paralysis, no movement. You can't move. That is, it's a complete paralysis, and it's called a flaccid paralysis. Because with disuse, muscles tend to become flaccid and eventually atrophy. Now let's take a second example, and that is a stroke in the motor cortex, in primary motor cortex. So in that case, can reflexes happen? So if this is gone, can reflexes happen? Well, yeah, they can, and they do. In fact, they're, for reasons that are a little bit unclear, or a lot unclear, they're exaggerated. In the presence of a stroke, if these neurons are killed, the reflexes are disinhibited, and they're very exaggerated and brisk reflexes. Can these central pattern generator actions occur? Yeah, they can. So the person can still walk. The person can still chew. The person can still do a lot of stuff, but the person may not be able to, for instance, if there is a problem, let's say with the left leg after a stroke, and you say, lift your left leg, the person can't do it. They got no access to this cortical motor control center. But if you watch them walk into the room, they'll walk into the room. They'll do it a little bit funny. They'll circumvent. They move a little bit more from the hip and a little bit less from the ankle, but they're still walking, and they're not falling over, and they still have posture. So you can see that in that case, these things are still working. This is still working. They're different, but they're working. This is not working. One last thing, which is that this is a motor hierarchy, and the reason we call it a hierarchy is because the top stuff talks to each of the bottom pieces. All right? So cortical motor control centers, they talk to brainstem motor control centers, they talk to central pattern generators, they talk to motor interneurons, and in some cases they talk directly to motor neurons. But there's no talking back. Motor neurons don't talk back to here. This is a hierarchy. The tops talk to the underlings. The underlings can't really talk back to the tops. And there's, with a little bit of an exception right here, which is that the motor neurons and the motor interneurons are interconnected. But in general, this is a hierarchy, top-down hierarchy. Okay, so in the next segment, we're going to look at how this motor hierarchy is modulated.